everyone. Today, we have a really interesting topic to talk about. Well, at least it's interesting for me, because it's security. So I'm Anastasiia, and I'm a software engineer. As you might know, I was working on mobile applications for ages. And on some point, I realized how much sensitive data users do put into their apps. And mobile developers mostly don't care about it. We believe that Apple will handle everything. But that's not true. Now I'm working in a data security company, and my work as a product engineer to make sure that our security products are easy to use and are developer-friendly. Oops. So, for example, Themis is an open-source library I maintain. It's easy to use for transport encryption and for storage encryption. And sometimes developers approach to me asking questions like, can you help with security in our app? And even when they're using good encryption library, I still see the same mistakes again and again. Let me show you something. This is a paper that was published a year ago. The guys have analyzed 300 vulnerabilities and divided them into two major categories. So one category is vulnerabilities that were caused by bugs in crypto libraries or algorithms. And another group are vulnerabilities that are caused by misusing crypto libraries. Can you guess the numbers? Let's guess the number. What is the percentage of bugs are made inside crypto libraries? Number, integer expected. 6? How much? 60? No? 10? 5? Any more ideas? 110. Not really close. OK, it's 17. So the majority of issues were caused by misusing crypto libraries by applied developers, basically by these hands, right? But cryptography is not the only one source of mistakes. Even when developers create their apps with security in mind, hiding plain text data and protect user secrets, attackers can find ways to bypass security measures using architectural weaknesses and unobvious but very simple vulnerabilities. So encryption is known to be like ultimate data security measure, like walls, like super secure gates. But each system is as secure as the most securest component in it. By the way, this is a real photo I took in San Francisco. So if someone can steal user password using fake alert, encryption is useless. And today, we're going to talk about all these bits and pieces that are necessary to make your app more secure against simple vulnerabilities before doing really complicated things like encryption. So, among these easy things, we're going to talk about handling user secrets with care, input validation, careful logging, handling transport connection, and some tips and tricks that can confuse attackers. But let's talk about sensitive data. This is a definition from GDPR. In short, any data that can identify the user should be protected. And this is top 10, or I would say top 5, because I have cut the image, reasons of app rejections by Apple during April. You can see the reason number 3 is bad data collection and storage. And the 5th reason is also about privacy. It's about accessing and using geodata. Let's talk about privacy. First mistake I see really often, and I'm sure you also have seen it, is showing sensitive data on the app screen during app switching. I can name you like at least five bank applications that show your card balance during app switching. I can name you secret chats that do the same, but it's really easy to implement. All you need to do is to implement app will resign active and add some black subview on your window, then remove this subview on app did become active. Super easy. Some applications prefer to take a screenshot and to blur screenshot. It's also fine. I recommend you doing this on any screen in your app when you show protected data. Because if user press the home button, this data can be shown during app switching, right? And I found a library for that. The library name is Screen Shield Kit. They claim that they can intercept any screenshot, including screen recording and QuickTime recording. They are closed source, and they have this patent-pending technology. I haven't used this library, being honest. I'm super curious how they work. If you had chance to use it, just let me know, because I'm really curious, you know. I saw videos on their site, and this looks really promising. By the way, do you remember this blog post by Felix? Felix, say hello to UIKonf. So this is a blog post about camera permissions. Basically, if user has granted camera permission, your app can take photos from front camera, back camera, use face recognition, face detection API without showing it to the user. And, well, you know this golden rule of permissions. Check what permissions you're asking. Don't ask permissions you don't want, don't really need, and don't do it immediately. Of course, on Android, things are even worse. But the idea is to minimize the amount of data your application works with. Moving next to the input validation and password rules. So the point of input validation is that when done correctly, it can stop a number of attacks you cannot foresee. You might need to limit a reasonable amount of characters for name, for email, and what is more important, when you're doing mobile app, the input validation should be on both sides. You should validate input on the app, and you should validate input on the server side. Basically, in any microservice of your system where you get the data in, you should validate the data. Password rules. This is the most common type of input validation. And usually bad password rules are like everywhere. For example, here, they want to put a customer ID that is above 6 characters, below 12, excluding 9. What? There is another joke about it, that the password should have emoji, hashtag, and video. What? If you know, May 3rd is the World Password Day, so Nutella has suggested to use the word Nutella as a password. Never use it, okay? I'm sure it would take attacker less than a second to crack this kind of password. What are the good password rules? Size matters. Longer passwords will take more time to crack. Basically, that's it. You should not limit the amount of characters. You should not limit the characters themselves because it decreases the entropy. You should disallow using typical passwords like Nutella, QWERTY, God, sex, love, you know the things. And of course, promote password managers and password generation tools. Next, in our application flow, next thing is authentication. Do you know the story behind Nissan Leaf? Several years ago, Nissan Leaf was hacked through the app because they don't use authentication in their API. So basically, people just got to the car parking with Nissan Leaf there, brute forcing the car ID and making server requests. And they were able to turn on the car, to open and close windows, and so on and so on. The idea behind it that if your authentication is bad, your application is not secure. How to make auth flow better? Again, nice blog post by Felix. Don't ask user passwords all the time. Because now on iOS, we can create fake alert, like not real Apple alert that asks for the password. And of course, you are good developers, but you can use nasty third-party libraries that can show this kind of alerts. And if during your application flow, you ask users for alerts again, and again, for passwords again and again and again, users can get tricked and put their passwords here. And of course, Touch ID, Face ID, multi-factor auth, they are good, they should be used. I won't explain you how to set up Touch ID. I'm sure you're able to do it. If you're curious, another blog post here. Then, since last summer, we have this nice SF auth session that helps to do single sign-on with web services that has auth flow. Have you used it already? Anyone? 1, 2, 3, 4, 5, 6? Okay, near 10 of you, maybe 20. This is a good thing to use to make your auth flow better. And of course, password autofill. You can use iOS 11 API and set up UI text content type as username or password, and your users will see this small key icon and can press it, and they can select which account to use. If you want to connect your application to your website, you can add associated domains to your app and a special file to your website for iOS to recognize that the account is basically the same. This is good. Use the things. Making auth flow better and less complicated for users is good. Yet, you should ask user password anywhere when the user is accessing or changing their personal data. And one more thing. Please test your login flow. Do you remember macOS High Sierra, right? Just double enter, and you can log in as a root to the system. If you haven't read the whole story, there is a link for you. But you might use UI testing to do this kind of checks. OK, moving in our app flow to the storage. Basically, lately in Ukraine, we had a small cybersecurity incident. The largest Ukrainian work site, like job offering site, has sent passwords to one user in plain text. And suddenly, that user has some connection with security, so he starts asking questions like, people, do you store my password in plain text? And people from Roboto.ua, they responded, no, we have really good encryption. Well, you can guess what happens next. Of course, they got cracked, the user database got leaked, and that super good encryption was solved. And here we got all these passwords in a plain text. And if you know Russian, there is a word Petrovich, which means son of Peter, written in Russian, on Russian in English keyboard. So it's a real user password here. A lot of companies got hacked. And it's not surprising. But storing secrets in plain text, that surprised me. In cryptography, by sensitive plain text, we understand not only passwords or credit card numbers. Basically, that's everything that can identify user. Document pictures, phone numbers, license plates, home addresses, navigation routes, and so on, so on, so on. Try not to store the things, but if you do, be bold, use proper encryption. And it's not only about storing. macOS again. So, after you can log into the system as a root by double enter, They have your password in plain text stored in some log file. And a lot of companies put passwords in a log file, like Twitter. It's one of the very typical mistakes, but there is a tool for that. The tool name is, I'm not very into French, Clouseau, I believe. It's like Inspector Clouseau from Pink Panther. So this is a static analyzer that can analyze your code, finding passwords, keys, and other credentials you forgot inside. Of course, if you print password into log like variable, this tool won't help you. But anyway, keep an eye on your logs. We like open source, but some things should not be open source. Like iBoot code that was leaked in February. Apple has filed copyright request to GitHub and they take the repository down. But basically, keep an eye on everything that you publish on GitHub, like keys, like API tokens. There are easy ways to handle with that. You can put all this, if you don't want to encrypt the keys, at least you can put them to the different file and add it to gitignore. Or you can use tools like Git Secrets or Cocoa Pod keys by Orta to avoid committing keys. Do you use any techniques to avoid committing your production keys? Anyone? 1, 2, 3, 4, 5, 6? Okay, so maybe 1/5 of you. For everyone else, please keep an eye on that. Okay, moving in our application flow. Transport encryption. Well, that's obvious. I don't want to talk about ATS, okay? I'm sure you know everything about it. I don't know when Apple will start rejecting applications that disable ATS completely, but at least if you can't enable it for everything, at least you can disable it for web UI. And of course, when everyone is using SSL, the problem is to configure SSL correctly. It's not the easiest part, being honest. What you need to do is to use long private keys, is to obtain certificate from reliable certificate authority, is to use strong cipher suite, and if you can, use TLS 1.3 or 1.2 at least. If you have mobile website, or any website, enable HSTS header preloading, which means that browser will remember that your application, that your site requires SSL connection always. Ssl pinning, my favorite topic. Please raise your hands who is using SSL pinning in your apps. Woohoo! Yay! I'm asking these questions like on almost every security talk I do to mobile developers, and I'm so happy to see that the amount of hands are growing. The idea is simple. You can pin the whole certificate, you can pin the public key. If you know nothing about SSL pinning, this OWASP guide is for you. This is a piece of code by Alamofire. Super simple example how to pin public keys. Of course, there are tricky things with SSL pinning. You should keep an eye on your certificate expiration, and probably you should have several active certificates at the time. But still, it's easy to solve. However, SSL itself, SSL TLS, like technology, is centralized system, which means that you can obtain totally legit SSL certificate using unlegged ways. Do you remember the WASign story? Yes? No? Okay, so WASign is a certificate authority from China, if I remember correctly, and they are famous by the fact that one user was able to obtain certificate to test.github.com, but he was not the owner of github.com. So WASign was signing certificates for people who are not the domain owners. And 2 years ago, Google stopped working with WASign, Apple stopped working with WASign, Mozilla stopped working with WASign, but In China, in Kazakhstan, governments can obtain certificates, SSL certificates for sites like google.com and provide you a governmental man in the middle reading all your communications, because SSL is centralized. It's not only about certificate, it's about certificate authority as well. If you use really sensitive data in your app, you might need another layer of encryption above SSL. This is an example of semi-secure session, is an encryption layer above WebSockets. Really easy to use, just put keys and start session, and you will get end-to-end encrypted channel, you will get forward secrecy with rotating encryption keys all the time, you will get strong cipher suite, and so on and so on. Well, I'm obviously biased, okay? I'm working on the things. Let's move forward. Xcode Ghost. Do you know the story about Xcode Ghost? Do you want to hear the story about Xcode Ghost? Yes. Okay. So, Xcode is really large. 5 gigabytes, 6 gigabytes, it takes you ages to download. In China, they have this golden firewall, right? And the connection is super laggy. So what people do, they download Xcode from Apple and then put it to the torrents inside country, so developers can download Xcode from torrents. But this is the trickiest part. Somebody has hacked Xcode and add malicious code in it. So developers who were downloading Xcode from torrents got this malicious version of Xcode, which was totally okay while you're developing. But when you were going to push your application to the App Store, this malicious Xcode adds some malicious code into your app that grabs user credentials, all sensitive data, and puts it somewhere on their servers. This is why it's Xcode Ghost. Of course, Apple noticed this thing, and they banned all the applications. But the main idea behind it, don't download anything from not secure channel. For us, it's not only about Xcode, of course. It's about libraries like CorePods. It's about EDAs. It's about tool you're using. Again, nice post by Felix. So if you use non-secure channel, anyone can intercept the connection. And instead of downloading good library, you can download malicious one without even knowing about it. So think, if you really need to use this library, read this awesome blog post, check the server certificate, check the hash sum of the downloaded binary. And if you're under GDPR, check what kind of data you're gonna share with this library. Maybe you don't need it at all. Because it's your responsibility. It's your app, it's your responsibility to take care on all these third-party libraries. It's up to you to see, to check. If these libraries has critical bugs, if they have security vulnerabilities, it's up to you to patch them. Of course, there is a tool for that. As you know, GitHub introduced security alerts, which are working for JavaScript, Python, and Node.js, and Ruby, I believe, right? And I recently got an update from Npm that they have new command Npm Audit that will check your Npm libraries. But for us, for mobile developers, I found these two tools. They are plugins to your continuous integration process that checks your libraries, your dependencies, and they are analyzing the open source, the open vulnerability databases, like OpenCV databases, to find if this open source library has known to have vulnerability in it. And if they find, they can monitor you. And some things are really smart. They can show you exact commit where this vulnerability was fixed, so you can get this commit into your code. I haven't used this too, okay? I checked with white source. I think they have plugin for Objective-C and Swift. Snyk, I asked them a question in Twitter like, do you support iOS? Because they support server-side platforms. They didn't respond me, so I don't know. But I'm telling you that third-party libraries are your responsibility, and you should keep an eye on them. OK? OK, we will. Thank you, Anastasiia. You're welcome. That's not the end. That's not the end. So, other fun things to do. We are still, if you remember, this is the talk that is called like X things you need to know before implementing cryptography. So we are talking about easy things, OK? Other easy things to do. When I talk about key protection, a lot of people think about obfuscation. There are different ways to obfuscate keys. You can store them like hex variable. You can permutate strings like characters inside. And obfuscation depends on social engineering. So the goal is to confuse attacker. You can experiment. You can put your own techniques. For example, you can save certificate but rename it to MP3. You can rename your XIBs and NIBs. Because I know the application, the macOS application, that is being targeted, that is a target for like making malicious clones of this app. So they just copy all the NIB files and create similar looking application and spread it into the same world, into the same name. So, and of course, there are some obfuscation tools for iOS as well. Do you use any obfuscation techniques? Anyone? 1, 2, 3. Do you find it helpful? No? For me, it's not really helpful, but fun. Of course, there are plenty of other things to do. Mobile applications, they don't live in a vacuum, you know? There is a server side, there is a whole infrastructure behind. So, set up firewalls. Set up intrusion detection systems. Do you know what is CM? This is a system of analyzing logs and events of your apps, of your infrastructure, and showing you alerts if it detects some suspicious behavior. So when you're logging anything from your whole infrastructure, you should need to have something that is watching these logs, right? Another fun things are honeypot and fake targets. Do you know what honeypot is? Yeah? So this is something attractive in your app, like fake encryption key, that is being put in a really attractive place. Like, please, attacker, use this key. Your real key is hidden. So attackers, like flies, fly to this honey and use this key, and it's up to you to monitor logs and to see, someone is using my fake key. Someone is trying to break into my system. I need to block these APIs, I need to block this client ID, and so on and so on. So these are fake targets inside your apps. If your application has in-app purchase, and for example, free user and pro user, maybe somewhere you have a method, check if user is pro. And it's easy. I know that a lot of apps are being hacked. They just change the result of this method to yes, return yes. If the user is pro, return yes. And it's an easy way to hack your app without digging in really deep. So it's up to you to set this kind of obvious method somewhere and to rename your real checks into something less obvious. And poison records. Do you know what poison records is? Should I explain? Yes? So poison records is, basically, let's imagine these are strings or binary data inside your databases that should not be read. So your application, your legit application, will never read these records. And again, the idea is the same. If you see that someone is trying to read this, to access this record, to read this record, and you are sure that your application is not doing this, this is somebody who wants to attack your system. You monitor it, you find suspicious behavior, you block suspicious behavior. Okay? Yes, yes. So, remember, if you do easy things, if you do complex things right, like encryption, but you are not very good in doing all these easy things, you are in a bad situation. I would say fucked up, but you're in a very bad situation, and your application can be cracked easily. So, let's talk about complex things. Cryptography is all about storing data, storing data encrypted, storage encryption, transport encryption, and key management. And of course, there is a lib for that. This is a super easy chart how to select library for iOS. In short, if you want to encrypt data in storage, you can use any good iOS wrapper. There are plenty of them. If you want to add some integrity checks to your stored data, I would recommend you to use libsodium if you're able to compile it on iOS, or Themis, which is easily compiled. About transport encryption, there are a lot of algorithms that solve the narrow use cases. Like, we can use OTR keyed for chat. If your use case is really broad, and if you don't want to rely on SSL, again, Themis secure session, well, I'm biased. Of course, there are plenty of libraries that are set of crypto algorithms. Not the box solutions, but a lot of crypto algorithms, and it's up to you to use them if you feel brave. If you know what's the difference between IIS CBC mode and IIS GCM mode. If you know what kind of padding you need. If you know what is Oracle padding attack that can happen if you're using wrong padding. So you may know it, and you may use libraries that provide you just algorithms. If you're out of this shiny world of cryptography, maybe you can look for libraries that have solutions in one method that you can use. So, let's wrap up. Remember the T-Mobile Twitter. Again, someone has asked, do you really store my password in plain text? And T-Mobile says, yes, why not? We can be hacked because our security is amazingly good. Never do the same. Of course, like few hours ago, several hours after that post, they got hacked, and this nice alert box, what if our security is amazingly good, was shown on their website. There is no amazingly good security, okay? Nothing is really secure. At least don't say it is secure. So, let's wrap up the whole idea. Developing your app, you should control the whole data flow. Maybe you don't need to store some data. Maybe you don't need even to collect some data. Obviously, maybe you don't need to store this data. But if you do, you should use a proper encryption, because this good encryption can be easy to break. Hide the data from spying eyes. Don't log it. Don't show it during app switching. Remove data as fast as you can. Keep an eye on all your dependencies, because it's your responsibility. Monitor all these things. Block suspicious behavior as fast as you can. And analyze your system. Try to find really easy to break things and to make them better. I know that you like reading about security. So I have prepared a list of links for your home reading. And you might notice this presentation had 50 different links. Some of them are on Twitter, like on Twitter posts, but some of them are really useful. If you want to go more deep into security, these are like, hand-picked links for you. If you're interested in other topics like how to build zero-knowledge application, what is the best key management technique, what is a boring crypto, and why the boring crypto exists, there are some other slides that I did. You can check them. And thank you.
Thank you very much, Anastasiia. We have time for a couple of questions from the audience. Do we have any questions?
Do you have any questions? Anyway.
There is one over there.
Okay, just before we start, anyway, I'm going to be here till tomorrow after lunch, so you can find me here, you can find me in Twitter, and ask any questions about your apps. So, what kind of question do we have?
Yeah.
Is there a honeypot link in your talk?
Is there what?
Honeypot link?
No. I'm pretending to be good, okay? So I'm pretending to be good, white hat, and all these things, so feel safe.
Over there.
Hi, so you told us about obfuscation, but for seasoned attacker, I think it's quite easy to de-obfuscate whatever you did. So does it make sense even obfuscate something?
You see, that's true. I told you about obfuscation on the end in this section other fun things to do. So obviously, obfuscation is not your first security step you should do, okay? There are so many serious things you should handle. Obfuscation is more like fun, additional step you can do to make your security more, to make your app more confusing for attacker. It's not a silver bullet. If you don't have time on it, don't do it. Spend this time on more serious things. Okay?
Last question.
What's the goal from blocking screenshots? You mentioned before there's a library to do that. If at the end one can take a picture with a different device, I missed the goal of blocking screenshots.
Well, sometimes an application like in chats like Telegram secret chat, for example, you know this feature, if you're in a secret chat and you take the screenshot of like secret chat that was supposed to be gone, they show in the chat that, hey, opponent has taken screenshot. So it's an indication for someone that you are sharing data that can be like leaked by screenshot. So if you're super paranoid and if you're working on an app with this kind of functionality, like Confide, the chatting application, like Telegram secret chat, if you have any really sensitive data on your screen you don't want to be screenshotted, I believe that's the reason behind it. And they claim to block screen recordings as well. So if you have like sensitive content that you can actually record and watch and send someone.
Yeah. But if I can take a picture using a different phone of that conversation, then what's the final goal of it?
It's not an ultimate measure of security, of course. But to take a picture of from different phone, you need to have this different phone, right? This is an additional step. All these things are just additional steps that you can improve in your app. There is nothing like super secure. You can make one security measure, add another security measure, and another security measure, and another, until it can be really complicated for attackers to spend time and money to crack your app. That's the whole idea behind. But you're right.
All right. Thank you very much.
You're welcome.